The cogeneration plant is really the heart of our district energy system. And I think an important thing to understand is that if we have 150 buildings that we're serving, and there's maybe 12,000 people on our campus as the daytime population. Normally, without the cogeneration plant, we'd need 150 boilers and 150 air conditioning systems. With a central energy plant and district energy, I'm able to have 3 boilers and 8 chillers instead of 1 in each building. There's 3 major pieces to the energy complex. The furthest is the cogen plant. That's where we make all our steam and electricity. The middle section is the chilled water plant, and that's where we make chilled water for the immediate cooling needs of the campus. And then the glass and stone building was built as our thermal storage plant. The thermal storage plant is really about buying electricity when it's inexpensive and cooling the water that we use for cooling the campus, and then delivering that water when the value of electricity is quite high. It's the thermal storage plant. We have a variety of electric and steam-driven equipment and large equipment and small equipment, and we value that tremendously because then we can pick the most optimal piece of equipment on any given day for the environmental conditions and the campus demand. The hot exhaust from the gas turbine leaves this way. It's about 950 degrees Fahrenheit. It goes out through a catalytic converter to absorb the carbon monoxide, and then it turns the corner and will go through this boiler to capture the heat. We take all the hot exhaust gas and use that to turn water into steam to heat the campus. A typical central power plant might be 25 to 45% efficient, but by doing a cogeneration process, we're able to double that or even more. If I put 1 unit of energy into the gas turbine, I get about 1/3 of that unit of energy out as useful electricity, and about 2/3 comes out as hot exhaust. So by capturing that waste heat or that exhaust heat, now our overall process is 70 and can be as high as 80% efficient. And the whole facilities engineering department at Princeton is working very hard on reducing our environmental footprint. Our new neuroscience laboratory is being built to very, very high energy efficiency standards. Similarly, our new chemistry laboratory, the Frick New Chemistry Laboratory, is built with very, very high efficiency fume hoods, and they're used only as much as they're needed. So in lots of ways, we not only improve the efficiency of our production, but also reduce our total use. Over the 25 or 30 or even 100-year life of some of our utility investments, we save much, much more than it costs us to build the equipment, and our environmental footprint is much, much lower by using district energy compared to distributed individual boilers and chillers.